Hello, I'm Rishabh Shirgave. I'm data engineer. I've experienced 3.5 years in data engineering as a data analytics and data engineering like Apache Iceberg and Snowflake, and almost 3.5 years experience in fintech, e-commerce domain and edtech domain and research development domain. And recently we started a new course with Apache Iceberg that from basics we need to start now. Let's enjoy my video.
Apache Iceberg Crash Course, Part 1. Welcome everyone. Today we're starting a journey into modern data architecture with Apache Iceberg. In Part 1, we'll understand what exactly is a data lakehouse, why we need a table format in big data environments. This sets the foundation for future lessons on Iceberg's architecture and capabilities. Traditional data systems vs data lakes. Traditional systems like databases or warehouses provide structured schema, catalogs, query processes with ACID guarantees. But data lakes only offer raw file storage without a proper schema or queryable structure. This causes challenges for managing and querying data at scale efficiently. What is a data lake? A data lake is a centralized repository where we store all data, structured and unstructured, at any scale. Think of it as a file dump. It stores files like Parquet, awk, CSV, images, videos, JSON, etc. But it lacks traditional database features like schema enforcement, transactions, or metadata management. Tools like Hadoop or AWS S3 typically back these storage systems. Traditional systems like databases or warehouses provide structured schema, catalogs, query processes with ACID guarantees. But data lakes only offer raw file storage without a proper schema or queryable structure. This causes challenges for managing and querying data at scale efficiently. Visualizing the data lake. On the screen, you see a lake storing multiple file types. Parquet files for tabular data. Images, videos, logs, and text files. But again, there's no concept of a table or metadata to manage them. This makes operations like querying and updating difficult and error-prone. What is a data lakehouse? A data lakehouse combines the benefits of both scalable storage from data lakes, query capabilities and schema management from data warehouses. It allows tools like Dremio or AWS Athena to query the data directly from object stores with SQL support and optimized performance. Table format explained. This is where table formats like Iceberg, Delta Lake, or Hadi come in. They define how metadata is stored and updated, handle schema evolution, enable efficient updates, deletes, partitioning, and time travel. Without table formats, data in object stores is just disconnected files. A lakehouse consists of 4 key components. Storage, Hadoop, S3. Compute engine, e.g., Dremio, Spark. Catalog, tracks metadata, schema, and table versions. Table format defines how files are laid out and managed. Together, these provide a powerful yet flexible analytics ecosystem. Table format explained. This is where table formats like Iceberg, Delta Lake, or Hadi come in. They define how metadata is stored and updated, handle schema evolution, enable efficient updates, deletes, partitioning, and time travel. Without table formats, data in object stores is just disconnected files. Understanding Parquet file structure. Let's look at a Parquet file. Contains row groups and footers. Efficient for columnar storage and read performance. However, using Parquet alone doesn't give you table-level capabilities like versioning or consistency. Multi-file dataset example. Imagine you have 3 files, users 1, Parquet, users 2, Parquet, users 3, Parquet. Each file is valid and structured, but how do you treat all of them as one logical table? Without a format or catalog, tools need to manually discover and scan them, which is slow and error-prone. The Hive approach to tables. Hive used a directory-based system for tables. All Parquet files were dumped into a folder. Problems with Hive. File listing overhead on large datasets. No ACID guarantees. Limited table evolution. Modern systems needed more flexibility and performance. Modern table format architecture. Apache Iceberg brings in a metadata file to track data files, schema, and partitioning. Query planners only scan relevant files. For example, users 1, Parquet, ages 20 to 30. Users 2, Parquet, ages 25 to 35. Users 3, Parquet, ages 30 to 40. So if your query is for ages 25 to 29, only 2 files are scanned. Benefits of modern table formats. Table formats like Iceberg offer many benefits. Checkmark faster query planning and execution. Checkmark time travel, query past snapshots of data. Checkmark ACID compliance, atomicity, consistency, isolation, durability. Checkmark efficient data mutation, update, delete support. Checkmark schema evolution, add, remove, change columns over time. Hands-on demo with Dremio. Want to try this yourself? Use Dremio Cloud or install Dremio software locally. Explore Apache Iceberg in action with GUI-based or SQL workflows. Understand snapshotting, version control, and optimizations visually. Additional resources. Stay updated and learn more from Dremio's Gnarly Data Waves podcast. The Dremio blog, great for tutorials and updates. Dremio community forums for real-world use cases and help. Apache Iceberg's GitHub and docs. Final words to summarize today. Data lakes are great for storage, but lack structure. Data lakehouses solve this by combining storage and processing with structure. Table formats like Apache Iceberg are the heart of this transformation. Next time, we'll explore the architecture of Apache Iceberg, Delta Lake, and Hadi.